So in this anti-aromatic, what is anti-aromatic property means? So look at this molecule. This is that B molecule. Look at this B molecule, which shows anti-aromatic property. So in this, and here you can identify this is the molecule having a cyclic nature, number one. The cyclic property it has, and since having this sp2 carbons also present in this, sp2 carbons also present, and molecule is basically ion. So ion means this is intermediate compound, this is, so having higher energy, so that means anti-aromatic compounds having greater energy. But if you observe this, in this the electrons, how many electrons are possible? That means this molecule follows 4n, the cyclic molecule follows, instead of Huckel rule, and following that 4n pi electrons rule system. So 4n rule matlab, so when n is equal to 0, sorry, n is equal to 1, when n is equal to 1, so there are 4 pi electrons are present. In this there are 4 electrons are present, lone pair and this pi bond electrons. So then following this 4n electrons rule it is following, then it is anti-aromatic. Or like, and look at this one. So this is that aromatic compound. In this 2 electrons are present. So following this Huckel rule and aromatic nature. And non-aromatic. So in this fourth case, look at this fourth one, non-aromatic case. In this, so there are 4 electrons are present, but so in this there are sp3 carbons also present. So that means if the molecule having sp3 carbons, the molecule having, so definitely, so this molecule is non-aromatic nature. That means here this molecule is having distorted geometry, or not planar, it is a distorted geometry because of sp3 carbon atoms are present in this. And look at this molecule, and in this aromatic, this also aromatic condition is there, alternate double bond is there in this, but here there is a carbon having the positive charge, and this molecule follows this Huckel rule and 6 pi electron system. This is 6 pi electron system, 6 pi electron system it can follows. And another molecule you can see, anti-aromatic molecule. So in this anti-aromatic condition there are how many? So here this also follows 4n electron rule, 4n pi electrons rule follows, it can follows. There are 4 pi electrons are present, anti-aromatic, this is anti-aromatic we say. And now you can see in this there are 4 pi electrons are present, and one lone pair electron is present, negative charge is present here. This is follows 6 pi electron system. This is 6 pi electron system it can follows, and this has aromatic nature. So this has aromatic nature we can say. Now look at this molecule. This is 6 electrons are present. 6 electrons are present, so this part is aromatic and this part not aromatic we say. So, and this can exhibit aromatic nature, means there is a possibility of so delocalization of electrons, so in this. And so next one also, this is aromatic, this is also aromatic compound, so having how many, so 6, and this can follow number of electrons you can see, and this having that sp2 carbons, planar molecule, cyclic molecule we say. So the cyclic molecule, and it can furnish that aromatic character. It can also follow, means delocalization of electrons is possible in this. There's alternate double bond also present, so planar molecule, and obeying that Huckel rule, so this also has that aromatic. That means here, so we can classify the molecules, hydrocarbons, aromatic, non-aromatic, or anti-aromatic, and fourth category is there, Homo Aromaticity. So what is Homo Aromaticity? So look at this Homo Aromatic molecule, that is tropylium is that ion. This is the ion. So this ion has that Homo aromaticity. In this Homo aromaticity, so what happened? This is a special case of aromaticity. So with conjugation means alternate double bond is interrupted by sp3 hybridized carbon. If the sp3 hybridized carbon so disturb the conjugation property, so conjugation means alternate double bond, so by the introduction of what is that, by introducing of CH2 methylene group. So when methylene group is added to this ion, tropylium ion, so then the Homo aromaticity property they can get. So due to the sp3 hybridized carbon, when sp3 hybridized carbon added means when sp3 hybridized carbon or when methylene group is introduced to this tropylium ion, then so homotropylium ion we can get. Further again one more CH3 is introduced. So one more CH2 is introduced in this, then we can get one more sp3 carbon we can get. So based on this, and here these are the ions, so are more stable and due to interruption by the sp3 hybridized carbon. So this property what we call means Homo aromaticity we say. That means so into the ion, so into what we call tropylium ion, if we introduce the CH2 or if you introduce sp3 carbon into this ion, then and that molecule that ion will be getting that Homo aromaticity. So these ions will get chemically stable. So chemically stability that molecules will get. Okay, so and this is about aromaticity or aromaticity of the molecules, and these molecules are more stable we say. And now come to this discussion about nomenclature and nomenclature of these aromatic compounds. So what nomenclature we follow? So here so the aromatic compounds, the nomenclature generally we write for example the benzene. So the benzene, see, and we must know the IUPAC name of the benzene. The benzene has 6 carbon atoms. 6 carbon atom. Benzene has 6 carbon atoms, and so there is alternate double bonds are present. So the first carbon, this is second carbon, this is a third, this is a fourth, right, fifth, and so then sixth, right? So here there are 3 pi bonds are present. So starting from 1, 3, 5. So then we can write, what is that right means? We can write that molecule. So basically this is a cyclic structure. So cyclo, so 1, 3, you can write cyclohex. Cyclohex is a cyclohexene. How many? So triple bonds are there? 1, 2, 3. 1, 3, 5. Triene. This is the IUPAC. Triene. This is the IUPAC name. That means the benzene generally, so we follow common names and systematic names, IUPAC names we will follow. So common name of the benzene is, common name of the structure is a benzene we say, and its IUPAC name is, since it is a cyclic structure, cyclohexa. So hex 1, 3, 5 triene. So is that IUPAC name of this benzene we write. So on this benzene, so if you remove one hydrogen, so then in that place if you introduce the OH, then it is said to be phenol. On the benzene, if you remove hydrogen is replaced by the OH is said to be what we call means, so this is called phenol. So phenol, we use the name. So even in IUPAC name also we write. And on the benzene ring, and the hydrogen is replaced by CH3, then it is alkyl benzene we say, and it is called toluene. Toluene we write. And on the benzene there is NH2, if you find, means that is called aminobenzene, then it is said to be aniline is the common name. And on the benzene, if you introduce OCH3, this is ether, so aromatic ether, mixed ether, we say this is anisole. And next, so here is on the benzene, there is CH2, CH2 double bond. This is a vinylic structure, and now this is vinyl benzene, or its common name is styrene we call. So this is acetophenone, and this is benzaldehyde. So this is the benzoic acid. So, and if you want to know further in this, along with the common names and IUPAC names, so benzene derivative compounds here. So here on this toluene, this is the toluene common name, and this is the toluene. Toluene compound is otherwise called methyl benzene. This is said to be methyl benzene. This is ethyl benzene. This is vinyl benzene. This is vinyl benzene. So this is isopropyl. The structure is isopropyl benzene. This is commonly called cumene. Isopropyl benzene is called cumene, and so this is a phenol hydroxybenzene, and so methyl groups are present on this 1 and 2nd carbon, 1,2 dimethyl benzene, and methyl groups are present so on so 1st carbon, 2nd, 3rd, 4th, 5th, or if you take this numbering like this direction, so 1,3 dimethyl benzene, so 1,4 dimethyl benzene, and this is methoxy benzene. Anisole is the common name. So this is the benzoic acid. This is the benzoic acid, and this is methyl. Sorry, this is nine. This is what we call means aminobenzene or benzamine or aniline we say. And next to this is nitrobenzene. This is benzene nitrile. Nitrile C triple bond N. This is benzamide. Benzamide. This is benzaldehyde. So we must know the names of these compound, common names and IUPAC names.